Oh, I'm not recording it.
You're
John.
not
Hang
recording,
on.
Nick. Oh, come on. I'll start us off. Normally, Nick does a bit of chatting. Good evening, everybody. We are Raw Pet Medics +1 tonight. We have a difficult subject in genes. Well, tricky enough for me. It's a complicated subject. So I am joined by three of the biggest dorks in the world. We've got dork Brendan Clark, dork Nick Thompson, and dork Victor Sandecki. So three of the top vets in the world are going to help us tease apart this study that is one of the foundational papers in the move to feed pets very vegan diet. This paper would come up in the top 3 studies that are cited as a support. So, such as if you were to look at the Omni website, you only have to scroll down, a couple of scrolls, and we're talking about the fact that dogs have evolved to eat carbohydrates and whatnot. And this paper is the sole support for that, because there isn't anything else out there that might suggest that. And we want to tease that paper apart. So thanks for joining us tonight, Victor. Appreciate that. Are you recording, Victor? Just to make sure.
Yeah, I think. I'm not sure it works properly, actually, because as soon as I connect my earphones to the computer, it stops recording on my iPhone. So
okay. Turn off your Bluetooth on your iPhone.
Oh yeah, very good.
There we go.
You always need a tech guy. It's like,
where would we be without you?
Perfect. I think we've got a lot to get through tonight, lads. So I don't even think we need to chat about what's been happening during the week. And
let's jump in. There's so much. We've already been talking about it for the last 20 minutes, actually. So
we're nearly done. We should have recorded it. Yeah. Listen, lads, I wrote out a tiny paragraph to explain to myself what this paper was about. See if you agree with my summation of this. 6 lines, okay? It's not just one study either. It's a few studies, but studies estimate that the AME2B gene, which is for releasing amylase from the pancreas. The AME2B expansion in dogs, they've recently noted, started around 5,000 to 7,000 years ago, coincided with the rise of human agriculture and the transition to starch-rich diets, at least our transition. Wolves typically have 2 copies of AME2B, that could be disputed, whereas domestic dogs have up to 20 copies of this gene, which can be disputed, leading to, they say, 50 times more amylase activity in these animals. And means more amylase means probably more carbohydrates being digested. This tallies with the fact that they are better with carbs than, say, cats. Okay, and that is true. When you inject glucose into cats and dogs can clear it in 40 to 60 minutes. Cats takes more than 90 minutes to clear it. So they have some sort of extra ability with carbs than we do, or than cats, true carnivores like cats do. Last little bit. We would assume, why is this relevant at all? Well, we would assume that dogs with more copies of AME2B would be better suited to hanging around humans, and they could extract more energy from the starch pickings that we would have thrown at them, because meat is not wasted on dogs, giving them better health, growth, and reproductive success if they could handle this new nutrient source. Over generations, these dogs reproduce more, passing on the AME2B gene to their kin. How does everybody feel about that as a general introduction as to what this paper is and what they say? How do you feel about that statement?
I'm going to totally jump into this, and I'm going to quote the great Jared Diamond. He wrote a book called Guns, Germs and Steel, which is a fabulous book for you nutrition and history of society nerds. And he says, and this is a quote that a lot of people talk about, the worst mistake in the history of the human race was the transition from hunter-gatherer to agricultural. Okay, so Jared Diamond, who studied this stuff, says that was the worst decision in the history of humans on this planet. And we know Omni and many other, and I think the Royal Canin and what have you, they quote this type of work saying dogs are omnivores, they can tolerate grain, carb, and therefore we should feed it. But actually, if you look equally, in dog populations where they're eating high ultra-processed food over the last 30, 40 years, the increase in obesity, in diabetes, in and all these modern diseases has all these things have gone through the roof. So if they're using this paper to justify feeding grain carbohydrate. Why are they doing that? Because it makes everybody sicker. And so from the off, they're wrong. There you go. We can go. We did that in 6
Guys,
minutes.
I'm now going to, 5 minutes in, call a halt. That's all
Let's
done.
go to the pub
Yeah.
now.
Yeah.
There you go. So the whole premise of the whole thing is wrong. So Omni is wrong, saying that they can eat it. They may or may not be able to digest it, but it makes them sick. It makes people sick. Which is why Kennedy is now in business in a really big way. It makes you ill. This stuff makes you ill. So
you remind me of Doug Canoovan's quote to Gene Dodds, where he said, I can digest sucrose and ethanol. Does that mean that 50% of my diet can be rum and cookies? Yeah. And it's like, oh yeah, just because you are able to handle something. But Brent, can you give us a very brief introduction when we start talking about genes and that sort of, can you give us 4 or 5 sentences on what we're actually talking about here, the production of these enzymes, how these things can replicate and become more in an animal over time through evolution?
Okay,
and then
so
we'll let Victor in, because he's going to explode if we don't let him in.
Yeah.
Poor guy.
Can we start over, guys?
He's been in and out.
I just think he's just dancing. I kept thinking he was going to the loo or something. But anyway.
He's nervous.
So, look, very brief intro. We all have a genetic code which is written down for us to produce proteins. Okay, very briefly, I'm hammering this to death. I'm really sorry. It's probably some geneticist out there who's going to just be having a little epileptic fit over what I'm saying. But let's simplify it as much as I can.
Yes, please.
So, genes produce proteins. Okay, those proteins can combine and be in various orders to create enzymes, and they have lots of actions within the body to effectively become the building blocks, or build the blocks together to create our cells and everything else that we have that makes us us. However, you also need to understand that the majority of genetic activity is happening outside our genes, and that's all of the epigenetic effects of all of the microbiome and everything else that is included in what makes us us. Coming back, therefore, to we have the similarity of genes with the fruit fly. I think 80% of our genes are the same as the fruit fly. So you can see how different I am from a fruit fly, hopefully, and therefore how different Nick is from me.
Depends on the light, Brent.
Yeah, okay. Anyway, so from a point of view of understanding that similarity, I mean, we're almost, I think, up to about 99% similar to a chimp, from our genetic code. You need to understand that mammals have a huge amount of similar genetic code, yet we eat quite disparate things. So you've then got to understand that we will all have some similar genes because that is just the way we evolved. Beyond that, then we say, oh, we've lost some genes. Realistically, we've got to always make sure that we're not talking about we've lost some genetic expression. So there's differences in that. And then there is this thing about genetic drift versus evolution. So a natural drifting of slight base pair alterations to actually what is then a true evolution towards a direction for survival. So there is that to go on. And then on top of that, you've then got true gene expression. So are those genes actually methylated and producing the enzymes that they code for, or are they switched off?
Are they on or off?
So just because you've got a gene doesn't mean you're going to express it. Yeah. So because you've got a gene for lung cancer doesn't mean you're going to die of gene cancer. That's kind of what we're saying.
And I forgot one more thing. And then even if you can express that gene, are you anatomically made up that you can actually utilize it in your system? So, for instance, if you don't have the ability to release the levels of carbohydrates, in this case, for that amylase to have action on. You've not masticated it to then create a bolus, to infuse that bolus with the amylase before it then hits the acid of the stomach, which is then going to inactivate all of those proteins. Are you then going to get it through into the intestine to then be acting to release the glucose from that carbohydrate?
That is to say, if you've got really rubbish teeth because you're a really old ancient dog, ancient as in, you know, prehistoric dog, then you're, whether you, even if you've got the amylase, you won't be able to digest that carbohydrate.
Well, even if
anyway.
you've got good teeth, because the teeth are just slicing, they're not grinding.
They're not even joining.
They're not.
But to bring us back to the point, okay, Victor, all this begets the fact that there are studies out there. This isn't the only one. There's a few more since then. There's 3 more on top of this, focusing on this subject. But this all ignores the fact that dogs do seem to have more copies of the AME2B gene, some breeds more than others, and they can pinpoint those breeds and say they are the breeds that evolved beside farmers, and the ones that didn't, such as Huskies and Akitas and a number of others that would have been raised more on a high protein and fat diet, didn't, as they would have expected. So where are we with this, Victor? What do you think?
No, I mean, even if I would assume that the study was correct in terms that, you know, some breeds have a better ability to digest starch than, let's say, wolves or other breeds, that doesn't make it healthy. It's a huge difference.
Excellent.
It's a huge difference to be able to survive periods of starvation or food scarcity, until you find what is good for you, right? So I don't mind my own personal ability to digest starch. I like to have that ability, because when there's not healthy food around, like I consider to be, you know, meat and fish or whatever, I can survive on bread for a while. It's not good for me, but I'm not going to die from it. I'm going to get sick from it after a few years, consuming only that. But it doesn't. I don't live in the illusion that it will carry on or carry me through a healthy life, so to speak. Right? That's the main difference. So I don't mind. I could say, yeah, interesting. You know, some breeds have more of this gene, and some, even if they were expressed, good for them. They're more capable to survive in different kind of environments. But this is surviving. And maybe this author says, you know, as he mentioned, thriving. Yeah, maybe he meant, or let's assume he meant as an option of dying. You know, surviving, that would be thriving if you compare it to dying or starving, right? So that's perfectly fine in my opinion. That doesn't mean I would pick that sort of food to feed my dog or a patient in order to, you know, keep them healthy. Why? Because like Nick pointed out earlier, there are thousands of studies on every medical database saying that consumption of refined carbohydrates, like for instance in kibble, will kill you, whether you're a human, a dog, a turtle, or a bovine or an equine, or many other species that actually are more adapted to a vegetarian kind of food, like horses and like bovine. When we feed them in our industrial complex with refined carbohydrates like grains, for instance, they do not thrive. I mean, that's not the point either with farm animals, is to make them grow fast so we can make food out of them. So it says nothing about health. And today's dog owners, and probably even maybe during the agricultural revolution or during the time of domestications, dogs were probably valuable, and you would want them to thrive, not just survive for a little bit. So that is the key question. Still, you know, what is best for a dog? And you know, the passion that current dog owners have for their pets, and they take care of them. They want to take care of them better than they do for themselves or friends or family members. Sometimes I think they have the right to know, you know, what the scientific articles on every database say that's good for you, or at least what is bad for you. Because to say what kind of food is perfect for you is very hard, because we're all individuals, and some might thrive on one kind of meat, another kind of meat. Some can thrive on maybe some potatoes every now and then, others do not.
Yeah.
But I also know that, you know, recently there was a few years ago, there was a book released by the publishing company Elsevier, you know, which is quite serious scientific publication called Ketogenic, and it actually gathered around all the data regarding low carbohydrate diet as a treatment for many diseases, which are thought to have come about of our modern day of living, which is caused by, increased consumption of grains, especially in high carbohydrate diet, which was recommended to us during the end of the 1970s for reasons, the food pyramid and everything that you learn about in school. I think actually it was from Sweden. Sorry for that. But
Thanks, buddy.
Actually, according to Encyclopedia Britannica, it's not really based on what's necessarily best for you, but food that are available and maybe affordable for you at the time.
It's
so
economics.
It was economics, yeah.
Yeah.
And it was invented by vegans. Yeah. Did you know the survive and thrive? The survive and thrive point is critical here, isn't it? That's you're totally nailing it there. Think, for example, if an alien came down and just picked me up off the planet and looked at me, and they found that I have alcohol dehydrogenase. It's the enzyme you need for digesting alcohol. So they found that in me, and I probably have more of that, certainly expressed, than most other people. And so that would be.
I don't know. I've seen you after a drinking session. I don't think you express it very well.
yeah, maybe not. But just because I can digest it, I have the enzyme more so than some races don't, as much as we do, and that's a problem for them when they drink alcohol. So just because I have expressed it more, it means I have bumped into it more. Okay, and that makes sense. I accept all of that. Through the last 1,000 years, my island has drank more than another island off the Pacific that never had alcohol. I get it. Okay, but should my diet be 50% alcohol? Absolutely not. Nobody would ever suggest that. And that's the word thrive there. You're spot on. When you look at people that use this study as a reason to feed all plant material to the dog, they say studies show they thrive. And so it's like, no, they don't. Yeah. Studies don't even show us they thrive on anything. We don't have those studies. We have a lot of circumstantial stuff that says less disease if you feed meat and blah, 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 blah. But we have nothing on thrive. We have no dogs on travelators with gas masks after 5 years eating this, It's just not available.
No, definitely. I mean, you're making a very good point with alcohol, definitely. But I think Nick, I think you mentioned it 2 years ago when we met the first time about the Western Price studies, and similar. When you the studies that we have on Thrive, maybe it's very hard to do. I suppose it would take a very long time, and you need a lot of people for it. But the closest we have is maybe not Aborigines, them as well, but many other people that are not involved in the modern civilization. What do you call them? These guys that live the Maasai, the Eskimos, whatever. They live on a pre-agriculture kind of food, more or less, and they are completely free of these diseases that we carry with us. And they live usually on basically more or less meat and milk and blood and maybe some wild flowers here and there and so on. So I think that's a very good example, the closest thing we can come. And also we could technically look at wolves. What are they suffering from? A wild wolf. I'm not an expert in that field at all, I'd say, but I think mostly it's about parasites or mechanical trauma due to fights or during hunting. Maybe starvation, but not so much maybe allergies and cancer and all that sort of weird stuff that we carry with us today. I mean, at least that's why I read. Or they get shot by us. That's a big thing. Being a wolf is dangerous, but they don't have these chronic diseases as we do. And I don't think these. I don't like the word primitive people because.
Ancient peoples.
Ancient or ancient.
There is a word. There's a word. I don't know.
Yeah. How it's a good example that they are also free from many of the diseases that we carry with us.
If you look in the book, by it's called Sugar. What's the guy? Gary Taubes. The case against sugar. He notes several. Because the Brits went out into the world and were missionaries and what have you, and we took white flour and white sugar out to these places, and as well as smallpox and all sorts of lovely gifts to the world. And we what they found is that in many of these very, very out of the way places where they hadn't eaten Western food, there was zero cancer. Cancer was virtually unknown in the human populations, and on average, it took 22 years of the missionary diet, the the white flour, the refined flour, refined sugar, refined oils,
right,
and cancer. We was like, oh my God, look, cancer. We've seen the first one ever. You know, they talk to the old chiefs and things like this. Like, have you ever seen these growths and what have you? So without a doubt, there is something in that.
Yeah. Bren,
sure.
Sorry, Nick. Sorry,
just the last point is, and just to get political, just or whatever it might be, you don't, guys who are watching here, welcome, but you don't even need to read the whole thing, because it is quite a potentially difficult thing to read the whole thing through. It ain't no novel, but you just need to read the introduction, the abstract, and the last paragraph, the last line says, our results indicate that novel adaptations allow the early ancestors of modern dogs to thrive on a diet rich in starch. Okay, they didn't use a neutral scientific word.
No.
They actually over-egged that sentence by saying thrive,
down.
and I think they could have been paid to do that. With great respect to Mr. Axelson.
It's a strange mistake.
Colleagues.
It's a strange mistake to make. No scientist writes that down without having done. That's a strange mistake to make.
Yeah.
I would question: is that because this was actually published in the letters part of Nature and not actually under full review? Because normally
zero review
actually put this for peer review, normally those sort of statements are the statements that are picked up, and that's why sometimes these rarities, as you've just stated, come through.
I didn't even pick that up. I'm checking.
It's a letter.
Published
on page 360 of Nature, volume 495. 21st of March 2013.
It's not peer reviewed. So that's interesting. That allows for that little bit of flexibility in language. Oh yeah, look at that big word letter on the top.
That's advertising. That's advertising. Somebody's twisted somebody's arm for that.
But it doesn't mean that what they found isn't correct. Bren, can you explain something to me? When we were looking at the breeds of dogs, there's another couple of studies since Freeman et al. In 2015, and what they found was differences within breeds, as we said, between breeds. Okay, so from Akitas to a Labrador or a collie that's evolved beside some bread-eating dude for 6,000 years, and some differences. But then they found differences within the breed. For example, in beagles, some beagles have 2 copies of the gene, and some other beagles can have 21 copies of the gene. So some beagles, when they tested them, had the same number of copies as a wolf and a husky and an Akita. In fact, the fact that they found huskies have the same copies of this gene as wolves, and Omni still use huskies in the front of their bags of food. So they use this study to say, look what we found. And they still use the
wrong breed.
Yeah, they chose the wrong breed. But it kind of shows the amount of science they're putting into it. But what is that? This idea of genetic drift compared to a forced selective pressure on dogs. Can you explain what that is?
Well, I'm sure that, again, I am not a premier geneticist, and I do not confess to be so. But my impression is it's not just the AMY2B gene expression. It's all of the other genes that would be associated with carbohydrate digestion that they are looking at. I don't think it was necessarily just the numbers of that particular copy. And I think there's also redundancy, because again, depending on how methylated those genes are as to whether they're switched on or not, will produce the number of proteins which are related. In this case, the enzymes that are related to that digestive activity. So the more you've got, the more likely you are to be able to cope with stuff. And I'm guessing the more processed foods, we're making assumption that this genetic drift started 40,000 years ago with farming.
Are we? No.
I mean,
what does Axelson say?
5 to 7.
Are we? Well, there's an interpretation of they've adapted alongside us with farming and carbohydrates.
We started farming 6,000 to 8,000 years
crops,
ago.
6,000, 7,000.
Whenever we started utilizing things, but from a point of view of, we can't time frame this to look back at where these genes were, and it may well be since sprats that a lot more genetic drift and the utilization of those enzymes are there purely and simply because we've got high processed foods going in. And
Sprouts being the 1868 or whenever it was, high carbohydrate, high biscuit, and horse blood
going biscuits,
meal.
wasn't it?
Yeah.
Animal Cancer Trust just came in there. It's nice to be joined by them. They said letters are peer reviewed in Nature. Very interesting.
Letters
they are peer reviewed.
Therefore, Nature let that get through. Which is
the 50% of the studies, they say.
We love it when somebody just corrects us. I just wondered because it was under the letters. So
that's interesting. There's studies there of rats, and they show that when you feed a rat high carbohydrate diets, the methylation of the gene increases very, very quickly. So they actually, the gene will work more. So if you're switching to a high carbohydrate diet, in a matter of days, so you can turn it on and you can turn it off depending on the diet you feed the rats. But now they found in just one generation, a male or female rat will pass on via sperm and egg. Epigenetically, those animals will be more geared up towards carbohydrate digestion just from one generation. So this has actually been known for 40 years. So this epigenetic bit, I'm not quite sure about that, but the high carbohydrate diets and the expression of this amylase has been measured in rats for ages because of the rat chow. So you can see how if they were on these high carbohydrate diets, how quickly, this isn't the same as genes change, and epigenetics changes quickly. Genes change slowly, so it would take.
And you can also imagine, you've got a pug that's been genetically altered, and its face is shorter, and its teeth are all at angles, and not necessarily able to eat anything except processed foods, compared to a husky, which you could have still been slinging carcass material to, and it's got a nice aligned jaw that can actually get through that carcass. A pug's going to struggle a little more, I would say. There's probably some pug owners out there that will say
they are going mad right now. I can tell you.
I think
my pug can get through a carcass.
It's interesting though. I wonder how many generations it takes, because they sampled dry-fed dogs for this. So dry-fed dogs eat dry food, and so they would have more expression of this gene. And they didn't test cats. Nobody's ever tested a cat. So cats have been on dry food for the last 60, 80 years. It'd be interesting if cats suddenly went up a couple of little steps. It's like, ooh. So force feeding these animals carbohydrates might force evolution in these tiny steps. As Victor says, that just means nothing about the health of the animal. It's just that it's being forced upon them. And so if you're measuring dry-fed dogs, what did you expect? We know when these dogs are let off the lead, truly feral dogs, they follow an all carnivore diet. It's only the dogs that grow up with humans and are fed this plant material that they ever incorporate plants into their diet. So it's not like they've stopped being carnivores.
Louisa has asked a very good point. Could they decrease the number of genes as well over time?
They can decrease the expression of
genes.
As they let's see, forever, but might they show gene expression? You see, the thing is, of course, we must be able to lose genes as quickly as we gain them. Otherwise, we'd have enormous numbers of genetic code by now, and it would be ridiculous. Would be tied up in knots as to which genes are we trying to express.
There's a study there, kelpies in kelpie dogs. 17 kelpie puppies presented with intestinal lipid malabsorption. So the ability to digest lipid is much higher in dogs because they're meat eaters, and much lower in omnivores and herbivores because they don't use fat for energy as much. So juvenile dogs exhibited stunted postnatal growth. What they found was this gene ACSL5, which is very prominent in dogs in the duodenal tissue. And it helps for fat absorption. That there's a little kink in these kelpies where the gene essentially disappeared. Sorry for my language here, guys. And it resulted in these dogs not being able to use these kelpies not to be able to use fat in the diet. So yes, there's the expression of these genes can have little hiccups here and there. That's genetic drift. And it's not always a benefit, as these poor kelpies found out. So sometimes you can have a little hiccup and it doesn't work out.
Victor, have you got any more major points that you'd like to bring to the table?
Well, I mean, I have these points that I call the limited sample representation as well for the study. There was a very limited amount of dogs that were tested, and same with the wolves. And even, the question is, the dogs or the breeds that were used, do they accurately represent the dogs that lived 10,000 years ago, for instance, right? Or how do we know that the dogs at that particular time have the same genes that the dogs have today? The breeds, for instance, it's not self-evident. And also, naturally, how do we know that the genes themselves came from an adaptation of starch when you can have definitely backbreeding with wolves in the area during the time of domestication as well? How do we know that the genes came from the dog and not from the wolf as well? I mean, there's so many uncertainties about this study that I'm quite not too happy about. But the strongest argument anyway is that, despite the fact that you can digest starch in those amounts doesn't make it good for you. That's the whole key. It doesn't matter so much what the study said, or if you have the ability to survive on bad food. Maybe it's good that you can, but it doesn't make it right that you should. And we shouldn't recommend it as vets or doctors in whatever field. Neither should a doctor recommend anyone else to have what do you call them, bagels or scones all day instead of a varied diet of fresh food and meat, vegetables, and so on.
Yeah.
So it doesn't say anything. It's a ridiculous argument, and it's false logic, in my opinion.
Yeah. And, there is 20,000 genes in the body, and 600 or 700 of them code for digestion. And we are talking about one gene here, AME2B. But when you go and search like the types of genes that the dog has expressed more of, it's for fat absorption and protein absorption and detox pathways that carnivores use, and everything else about their genetic setup. Like, you want to see, like, when you look at the top genes that are expressed in dogs, like when you compare them to true omnivores, they have all these different types of genes, but a lot of them are geared towards fat. So yes, omnivores have them too, as Bren said. We've all got a similar genetic profile. But in dogs, they're expressed much more highly in carnivores. There's about 6 or 8 genes there for fat absorption in dogs that are expressed far higher in dogs than they are in omnivores. Essential for, to quote the author, this one here is essential for lipid metabolism and fat deposition in carnivores. So this is ACSL5. This is a carnivore gene. That's a fat regulation, fat metabolism, and it's a thing that carnivores have. So that's it. Why don't we focus on that study? Why are we focusing on the ability to AME2B? And on top of that, there's about 5 or 6 others here. This is ACSL4. It's significant for breeds with a history of high protein, meat-based diets. PHYH. Involved in the oxidation of phytanic acid, a fatty acid that is found in ruminant tissue. So let's talk about that gene. It's like it's just ridiculous that they pick one, and then there's 2 or 3 more. That's this one, SLC27A1, supports efficient absorption and utilization of fats from meat sources. So on and on. The last 2 here, a couple of protein ones that are only found in carnivores. One's called PEP-CKC, highly active in dogs, not so much in omnivores. SLC7A9 facilitates the absorption of amino acids from meat. Its absence is suspected in certain breeds and cats getting cystinuria, which is interesting. Last 2, the detox pathway that Bren and Nick and Victor no doubt know about, which is the CYP2B11 gene, which is something that greyhounds lack.
Oh, that one.
Yeah, do you know that one?
Oh,
but do you know that greyhounds are poorer at detoxing drugs? I mean, they must be the most drugged up dogs on the planet, and they're the worst at metabolizing it because they lack this gene. And this gene, ironically, is
That's
a real
thiopentone gene.
Is a what?
It's an anesthetic agent we used to use.
Yeah,
it used to be a nightmare in greyhounds.
And they said, like, it's important, this gene that greyhounds lose, which make them really poor at digesting drugs. It's found in the liver. It's important for detoxifying xenobiotic lipophilic compounds from meat, ranging from steroids and hormones produced naturally to compounds that meat can produce when it's stressed and stuff. And so, like, these are all genes. The point is, there's lots of protein metabolizing genes and fat metabolizing genes, which is a real protein and fat. If you're a carnivore, you're using fat for energy. Why aren't we talking about those genes? They picked this one little tiny quirk, as Victor said. It's a tiny little quirk, and has been virtually forced upon many of them. They have taken advantage of it because they're such scavengers, and it's handy to get you through as some spare energy in times of famine and whatnot. Great. But to say that you're now going to feed it to 60% of, to a degree of 60% of their diet is idiotic. Why don't we focus on all the other genes?
And I will declare, it's come to modern science that actually, me and Nick both had this conversation before we came on air, that actually we don't even trust that they've said there are no conflicts of interest to declare in the paper. we're even, we're having, because of other papers where we know they're funded by larger companies to effectively generate their research, we sort of, we're looking at as saying, was there an alternate motive? Has this been funded by somebody that wanted a specific paper that said you can use high carb diets to feed this species?
Ooh.
Why not?
Because we're now so suspicious that we can't trust that it's there.
No, we can't.
There's no
a bit like the grain-free food debacle, which happened
DCM.
and lasted, and DCM and grain-free food that was manufactured to depress the market of grain-free food. Okay?
I would love it if they've
done it then. What's to say?
No, we actually had no conflicts of interest, and I can show you all of our funding, where it came from.
I'd like to see that.
But unfortunately, you become so super suspicious with all of the
there was
papers that are out there.
I read here, recently I read an article from the British Medical Journal. It said the illusion of evidence-based medicine from 2022 March. Like, evidence-based medicine has been corrupted by corrupt interests, failed regulation, and commercialization of academia, argue these authors. And of course, may mention what you did as well, Connor, about the sponsoring of huge companies to the universities, which sort of frames the mind of whoever is studying there, right? You don't know where the information that you get comes from, really. You can find out, of course, but it's easy to be led astray if you're not careful. For sure.
I think the findings of the study, I'm still on the side of that it's not so dodgy. I'm still of the belief that this is a really interesting finding, that it's opened up, at least to me anyway, who knows, I did genetics in college for a year, guys, and I couldn't tell you one thing about anything. And it was just, I found it so difficult. I actually enjoyed the first 2 or 3, and I thought, I'm going to like this, and then it just descended into just hell. But I still find it interesting. I think Darwin would have given his eye teeth to see these little tiny evolutionary steps. This is probably evolution in motion, that if you left these dogs long enough and forced enough carbohydrates into them, if they just lived in the Mars factory, in 100,000 years, would the dogs be able to healthily live on carbohydrates? Perhaps. They will keep adapting if they're free to choose their own mates, because your survival of the fittest and all that needs to take over. The problem is the captive breeding of sick animals, and so it messes with the... Anyway, so I think that this is interesting, that this is perhaps evolution in motion. This is what we're seeing at the scale. This is how we can switch on and off our genes, and I think it's fascinating. And I think that perhaps they did this study and then the vegan lobby went, "Ooh, this is perfect." A legit finding, but then they take that finding and then they do it for nefarious reasons. They use it to ridiculous ends.
But evolution is far more rapid than it should be through genetic change of the individual, because it's actually the epigenetic change of the microbiome that actually forces through faster changes to what they can actually survive on. So it's actually the real highlight should have been, okay, well, what happens when you change the diet of a standard wolf to their microbiome, and how they can adapt their microbiome to get the maximum out of that diet.
Yeah.
That's the crucial bit that really would be highlighting where change truly occurs.
Yeah.
Victor, you had something.
Yeah, Nestle, the company, right? Or
Nestle, yeah.
I've heard of them.
Yeah, have you heard of them? Yeah, it's something really ironic. They're writing the following in this book, right?
It's backwards.
Oh shit! Really?
Oh no, your camera, not the book.
No, just. You can twiggle your camera, but don't worry. Just read it out. Just read out the.
Right. They say that an apparent irony is that human nutritionists and the general public in developed countries are emphasizing diets based on largely on foods from plant sources, while in developing countries where most humans live, plant-based diets are associated with extreme poverty and poor health. When economic conditions improve, these populations increase their consumption of meat and display improved health.
Yes.
Ooh.
Nice.
Ooh.
Yeah. So that's what a kibble company says.
Whoa.
And they're not only a kibble company. Isn't that interesting?
Oh, that's an interesting quote. Send me that, Victor.
Yeah.
I'm surprised they said that. Yeah.
Nice from this. Yeah.
It's
a symposium called Meat or Wheat for the Next Millennium.
We talked
about it the last time as well. Yeah, the double-edged sword of the agricultural revolution, right? It gave us civilization and culture and exchange of knowledge and so on, but it also gave us poorer health. We got more food, but worse food.
Yeah, we got more calories. You know? But
that's exactly what Jared Diamond is saying.
That's
what
the guns, germs, and steel dude says.
We had bigger populations. He says so. There was a decline in health. We got shorter. We got worse teeth.
Yeah.
We had more work because we started farming. The population grew, which means there's more people, so we could spread disease. Social stratification was more complex, and therefore quality of life decreased. Environmental impact was worse. Loss of leisure, because we're working more, and dependency on food production. It meant the guy at the top could control you because he controlled your food. Kissinger said, "Control food, control the world."
Indeed.
So. And we're trying to hoist this idea on our poor dogs. Through this paper, for example. I'm sure that's not what they meant. I think Victor, you were saying you saw Axelson and that he appeared to have no mal intent with this paper.
Yeah, that is my subjective how I remember it, but it's like over 10 years ago, and I didn't see anything strange with what he said, and he didn't seem to emphasize or recommend anything either. It was just interesting to find that, look, if you compare the genes between 12 wolves and 60 breeds of dogs, you'll find that some of these breeds have a gene, more expression of a gene that could make it easier for them to digest starch. Maybe that will help them during the domestication, maybe not. He wasn't very pushy on that subject, as I remember it, and also his interest in communicating with other lecturers who were dealing with canines consuming mostly, thriving on protein and fat. I think it was sled dogs and stuff, and also other canines from different zoological gardens that are fed mostly meat and some fruit as well. He was I didn't see any connection there myself. Nothing seemed strange other than just a scientist.
I bet you that's
reporting what he observed.
I bet you that's right.
It's like it meant nothing. Like, so therefore, doing what you do,
feed cabbage
is good. Yeah, nothing like that. Feed cabbage.
Yeah,
or feed only bread. Feeding only bread is okay because I had this finding, and I saw nothing like that. It was quite interesting.
He could just be a geneticist that has fallen into this acid bath.
Yeah, and if you're not interested in nutrition or passionate about the long-term health of certain food stuff, maybe you don't choose those particular words that carefully, so you thrive. You do get the energy. My German Shepherd was happy running around for 7 years before she started to get in trouble, but still she could digest it. She could take the energy from the high starch diet. So she could utilize it, I suppose, because there would not come enough calories from the protein and fat alone. So, but the long-term health is detrimental. That's the difference.
Yeah,
right?
Totally. Yeah.
Has it been reproduced, this paper, at all?
Yeah.
In any way?
Oh, good question.
There is a few more studies. Yeah. There's
which ones are they, Connor? Because that's important, because this is a keystone to many kibble companies, the big boys at the top, the Nestle's, the Mars, the
Arendt et al. ARENDT. That was the next one. That was 1 year later. The very next year, Arendt et al.
What was the title?
I'll dig it up for you. I just took notes from it. It said she revealed a lot of internal variation within breeds. She was the girl that came up with 2 to 21 copies of the gene in beagles. So that was the question. And the very next year, Friedman et al. In 2015 found that in dogs breeds traditionally consuming low-starch diets, ABE2B copy number still varied, only now they put it down to genetic drift rather than positive selection. random genetic samples rather than dietary pressures may account for the observed variations for this between the difference within a breed. Genetic changes that are not necessarily advantageous either. So, 3 more studies came out after it, but they all did agree that some breeds of dogs have more expression of this, and those breeds were more likely to be living beside farmers of the last 5,000 to 7,000 years.
So just to double check, because you said expression there. So are you talking about?
I would be careful with me. No, be careful, because my words just like that person we were just talking about. I'm just grasping on. So like what I wrote down in that word file is just for me to have jog notes.
So within any one breed, there's a large variation. So you could select the bottom end of the
beagles. Beagles have 2 copies, and they grew up beside farmers.
Or you could pick the top end of beagles, and they'd have 22. Right. And so I'm not sure whether it says in the paper how they selected the 139 domestic dogs. They could have
selection bias. Yeah.
I'm sure they wouldn't. I'm sure they were very rigorous and randomly selected. It wasn't
giving them a very good idea. Anyway, Nick, if they
didn't. I'm sure.
I'll take commission.
Vicky will be saying it was peer reviewed. They'd have looked at how they selected that sample.
I bet they didn't.
What did Nicky Kamek say to you, Bren? Or it's 1947.
Let's do that.
We'll jump over
go
to
Patreon.
This is crucial information. This
is absolutely crucial. Just give us a little teaser as to what she said.
Oh, no, it's all about expression.
Okay, it's all about expression, guys.
Okay.
So let's, Victor, if you can stick with us for 10, 15 minutes, we're going to talk about expression, which is crucial to this paper. And we didn't deliberately...
Yes, we have to learn to express ourselves.
So now that everybody's got something to look forward to, if you want to join us over on patreon.com/Raw Pet Medics, you'll get a bit on the side with Victor expressing himself. So swallow it, Connor, swallow it.
This sort of talk is for a bit in the side. This is where we let go. We unbutton our shirts a bit more. But so thanks to everyone on Patreon, and we will see you over there in a second. And other than that, we will see you all next week. I'm sure we've got it's Q&A next week because it's an early month, February.
It is.
So good. Okay,
thanks everyone.